Hello all and welcome back to Level Up. I am Priyanka and today we are going to finish the first chapter of grade 8 mathematics, which is called rational numbers. This video is the third and the final part of the chapter. The links for the preceding parts of this chapter are uploaded in the description box. Now let us continue with the chapter. What is the negative of a number? Let us consider an integer a. So when we add positive a to negative a, or when we add negative a to positive a, the final answer remains 0. In this case, positive a acts as the negative of negative a and negative a acts as the negative of positive a. When we add the negative of a positive number to the positive number itself, we always get 0. No matter what the number is, what type of a number it is, the answer always remains 0. That is why the negative of any number is also called as the additive inverse of the same number. Now when we consider the same for rational numbers a by b, we have positive a by b plus negative a by b equals negative a by b plus positive a by b, which equals 0. For example, in this case, we have negative 3 by 2 plus positive 3 by 2, which cancels each other out. And then at the end, you get 0 as the answer. So, in this case, negative 3 by 2 is the additive inverse of positive 3 by 2, and positive 3 by 2 is the additive inverse of negative 3 by 2. Now, let us move on to see what the reciprocal of a number is. Let us consider a rational number c by d. That is called as the multiplicative inverse of another rational number a by b if their products give you 1. So let us look at the examples given below to understand it better. We have the fraction 2 by 5. We need to multiply this number with some number to give you the final answer as 1. How do we get this? When you multiply 2 by 5 with 5 by 2, which is the reciprocal, 5 and 5 cancels. Similarly, 2 and 2 cancels. As a result, you have 1 here and you have 1 here. 1 into 1 is nothing but 1. So your final answer becomes 1. In this case, the reciprocal of 2 by 5, which is 5 by 2, acts as your multiplicative inverse, as the answer always remains 1. Now, what if you have a whole number like 8? We need to multiply this number with some number to get the final answer as 1. For that, we leave the denominator as it is and we bring that up to the numerator. So we know that any whole number is nothing but the whole number by 1. We bring this denominator to the numerator and we bring the numerator to the denominator, and in such a way 8 and 8 will cancel, 1 and 1 will cancel to give you 1 as the final answer. So in case of a whole number, its reciprocal is 1 by that number. Let's move. Now this property is a property that we have come across ever since grade 3 or 4, which is distributivity of multiplication over addition. The main objective of this property is to simplify multiplication. For example, we have 3 into 7 plus 4. It's the same as splitting 3 up to all the numbers inside the bracket and adding them. In this case, we have 3 into 7 and then we have 3 into 4. 3 into 7 becomes 21 and 3 into 4 becomes 12. When you add the two of them, you get 33 as your final answer. Now, how does this simplify multiplication? Let us see that. 7 plus 4 is 11. Now, when you multiply that by 3, you get 33. This case was easy because you have 11 as the sum of the numbers inside the bracket. But sometimes you will have 100 into 42 In that case, it's going to be so hard for us to multiply this number with that number with the time constraint during exams. In that case, we can easily distribute the number outside the bracket to each element inside the bracket and simply add them. Now let us move on to see some examples. In the first case, you have negative 2 by 3 into 3 by 5 plus 5 by 2 minus 3 by 5 into 1 by 6. You first use the commutativity property, which is a property we saw in the last video, and you will get negative 2 by 3 into 3 by 5 minus 3 by 5 into 1 by 6 plus 5 by 2. Now you can distribute them and you will get negative 3 by 5 into 2 by 3 plus 1 by 6 plus 5 by 2, as negative 3 by 5 is common for both. Then when you simplify it, you get the answer as 2. The second question we have is also similar. You may pause the video here to check how the question goes, and if there are any doubts, you may leave it in the comment section. Now let us move on to see how to represent a rational number on the number line. We need to keep in mind few things. First, we always know that the positive rational numbers fall on the right side of 0 on the number line. Another thing that we always know is the negative rational numbers fall on the left side of 0 in the number line. So you can see an integer number line given below and all the negative integers falling towards the left of 0 and all the positive integers falling towards the right of 0. 0 is neither positive nor negative and always falls in between both of them in the middle of the line. We know what proper fractions are. Proper fractions total value are lesser than 1 and greater than 0. So proper fractions always exist between 0 and 1 on the number line. Even if the denominators or the numerators seem greater than 1 or greater than 0, they always fall between 0 and 1. For positive values. For negative values, they always fall between 0 and negative 1. As you can see, 1 by 4, 2 by 4, 3 by 4 are all positive values that fall between 0 and 1. Similarly, negative 1 by 5, negative 2 by 5, negative 4 by 5 are all fractions that fall between 0 and negative 1. Now we all know what an improper fraction is. An improper fraction is a fraction where the numerator is always greater than the denominator. So when you find the actual value of a fraction, it will always be greater than 1. So in this case, we convert the improper fraction into a mixed fraction so that we know where it lies in the number line, as in which integer it lies after and before. For example, we have 9 by 5. When we convert it into mixed fractions, you get 1 4 by 5. Since the whole number in the mixed fraction is 1, we know that it falls after 1 and between 2. Now what we need to do is we need to draw 1 by 5, 2 by 5, 3 by 5, and when you draw 4 by 5, its count will be 1 4 by 5. So this is the point where this fraction 9 by 5 lies. Now let us see something about rational numbers between two rational numbers in a number line. Between any two given rational numbers, infinite number of rational numbers can be found. Let us see how that works. Let us take your scale. From the count 0 to the count 1, you usually have 10 divisions. Now, within those 10 divisions, you have further 10 divisions. And within those 10 divisions, you have further 10 divisions, and that continues until its value becomes negligible. So, you have 10 counts from 0 to 1, and then within the 10 counts, you have 10 counts for each of the count. And that count continuously increases until you have a value like 0.0000000001, and that one never comes. The decimal is endless. So that is why between two rational numbers you can find so many rational numbers that you can't count it. Now, how to find a rational number between two given rational numbers with the same denominator? If there are two rational numbers with the same denominator, but their numerators have a huge difference, for example, you have one value as 1 by 8 and the second value as 7 by 8, you have a difference of 6 between them. So you can easily choose any two rational numbers between them and write as the answers. So whenever we have numerators with a huge difference, we can randomly choose any fraction between them. Now, if the difference is lesser than 5, where you can't choose any random numbers, you don't have that many fractions between them, we can make them into equivalent fractions. Now, how do we make them into equivalent fractions? We multiply them with either 10 or 100. So for example, you will have 2 by 5 and 4 by 5, and if you need to find 5 rational numbers between them, you can't, because between 2 and 4 there is only one number, 3. But if you multiply them with 10, you will get 2 by 5 as 20 by 5 and 4 by 5 as 40 by 50. In that case, you can easily choose any 5 rational numbers between this set of 20 numbers. So you can choose 21 by 50, you can choose 25 by 50, you can choose 36 by 50, you can choose 39 by 50, you can choose any 5 numbers between 20 and 40. Now, how to find a rational number with different denominators? In this case, we need to equate the denominators to find the rational numbers between them. So as a conclusion, you can say that the denominators must always be equivalent to find rational numbers between them. Now, how to make the denominators equal? It's just the same way you do to find the sum of two fractions. You find their LCM or you cross multiply and you make the denominators equal. Let us look at an example. We need to find 5 rational numbers between 1 by 4 and 1 by 2. As you can see, the denominators are different. One is 4 and one is 2. So we find the LCM to equate the denominators. The LCM becomes 8. So when we multiply them to make the denominators equal, you get 2 by 8 and 4 by 8. Now, you need to find 5 rational numbers and you don't have enough of rational numbers between 2 and 4. So we multiply these fractions with 10 and you get 20 by 80 and 40 by 80. Now you can pick any 5 rational numbers between 20 by 80 and 40 by 80 and write them. For example, I have chosen 21 by 80, 25 by 80, 35 by 40, 37 by 80, 39 by 80. Thank you. This is the third and the final part of this chapter. For the first two parts, click on the links given in the description box or on the videos given above. Thank you so much and hope to see you in the next chapter.